So on the final exam, the first, I'm going to say it's 60 multiple choice questions. I figured 60 questions, 80 minutes. That gives you over a minute per question. Most of them don't involve involve straight knowledge. Some of the electricity ones are going to involve a bit of calculating. I did not put solving circuits on your final exam. That was something I did just because I'm a nerd. But you are going to have to use the power, P equals V times I, V equals I times R. You're going to have to be able to handle those ones okay. If I tell you the current and I tell you the resistance, can you tell me the voltage? If I tell you the voltage and I tell you the resistance, can you tell me the current and all that stuff? The yellow sheet, I think it was, the bright yellow sheet was the formula sheet we used for electricity. Those formulas are fair game. Meanwhile, chemistry. The first, Jordan, 3 or 4 questions are on lab safety. 2 of them are really stupidly obvious, okay? I won't call them free marks because you actually have to read them and pick the right answer, but the wrong answers will make you smile and say, okay, that's clearly the wrong answer. So that's kind of to get you in. But then we're going to ask you some questions about hazardous materials. So from your textbook, I think it's near the beginning of the year. What does this one here mean? Good question, Mr. Dueck. You know what? Let's go Science 9, Chemistry. I think this is what I want here, Mr. Dueck. Oh, I don't have this 1.1 actually. Good gosh. You'll have to actually look. What page is this on in your textbook? Page what? All right, let's pause while everybody shakes the cobwebs off. So if you look at page 12, now what does this symbol here mean? How can you remember that this one stands for reactive? Okay, so I don't know which. I'm going to ask you one symbol. So this one here is reactive. This is an obvious one. What does this one mean? Quite poisonous. You would know this if you had opened your textbook up to page 12, and you could follow along. Make sure you bring your textbooks, please, next class. Otherwise, I will be hounding you like holy God to try and get them back. I'll make you come in early in the morning during your sleepy-in days to bring them back. I will. So make sure you bring your textbooks. What's this thing that looks like a T? There's a key word. There's a reason they have a letter T there. There's a way you can remember this one. What, Aiden? Toxic. What's the difference between toxic and poisonous? Poisonous means if you eat or smell it, ingest it. Toxic, I think, also includes if you like breathe it or something like that. I don't know. But toxic. Hey, what's this one here? So flammable, it burns. Now let's answer the question, which of the following hazard labels warns that the chemical is dangerously reactive? Okay. Which terms describe the formation of a solid from either a liquid or a gas? Okay, what do we call, what's the fancy word when a liquid becomes a solid? First of all, there's a slang term. What's the slang term? Begins with letter F. Okay, so that counts. What's the fancy term for freezing? Aiden, you're right. Solidification. By the way, whenever they give me a chart like this and then they say A only, B only, I always use X's and crosses on the chart so that I don't accidentally circle the wrong answer down low. I hate these kinds of questions, but they seem to really like these kinds of questions on the test and on the provincial next year. What's condensation? Condensation is liquid to gas. Okay, condensation is gas to liquid, like when you breathe on a window, your gas, the water vapor in your breath condenses into a liquid on the window. So this is not the right answer. What about deposition? And I always think like making a deposit. That's gas to solid. So what's the correct answer here? A, B, C, or D? First of all, I would probably go D is wrong and B is wrong. Why can I cross those out? Jordan, whenever they give me a chart like this, as soon as I put an X next to one of them, I cross out any answer that has that in there. Okay? And you know what? Probably what I could have done is if I'd crossed that out and then realized that I had two, it's got to be C. I can get there even without completing the whole question. Right? Which phrase best describes the physical property known as density? So if you look in your textbook on page 22, I am going to ask you one question about what some of those in that chart mean. Whether it's density, conductivity, we had ductility, malleability. I may ask you one question. So which of these is density? D. Now, did we ask it here? Okay. I'm also on your final going to ask you questions from page 20, the kinetic molecular theory. I think I have 3 questions in a row on that. So it'll be asking you things like, when you heat an object up, what happens to the particles, to the spaces between the particles? When you cool an object down, what happens to the spaces between the particles? What does the kinetic molecular theory actually say? It says, okay, atoms are small particles called atoms and all that stuff. So make sure you're familiar with that, with the kinetic molecular theory and changes in state. Also, I should say, page 18, the particle theory of matter. I put 2 questions on there. So if you're studying, look at that as well. Next page over. Which of the following best describes atoms? A, nucleus contains protons and electrons. Nucleus is surrounded by neutrons. The nucleus contains protons and electrons? No. Cross out A. Does the nucleus contain neutrons, and is the nucleus surrounded by protons and electrons? Which ones are on the outside of the nucleus? Which particles? Electrons. Which ones are inside? So, C is the correct answer. So you need to be familiar with what atoms look like. We'll also talk about valence shells and shells. The 2-8-8-18 rule, we'll talk about all that. Which of the following is a metal? So on my periodic table, which sort of looks like that, where are the metals?
On the left side.
And then we have non-metals over here. So which of the following is a metal? A, B, C, or D? Yep. B. Potassium is a metal. Okay. What do metals have in common? Can you tell me some things that make a metal a metal? What kind of a charge? This is very important. All positive. They want to lose electrons, which is why when they become ions, they become positively charged. Nonmetals want to gain electrons, which is why when they become ions, they become negatively charged. And then you learned in electricity, when you have a positive charge and a negative charge, unlike charges attract, and that's an ionic bond. What's meant by the term group in a periodic table? Oh, okay. So here's my terrible drawing of a periodic table. Let's try that again, Mr. Dueck. Sort of looks like that, kind of. I know there's kind of a thing there, too. We have vertical columns, and we have horizontal rows. What's the fancy word for the horizontal rows? It begins with letter P. Those are periods. It's why it's called the periodic table. Each thing in one row is in the same period. What that really means is, Nate, they have the same number of electron shells. Different number of electrons in the valence shell, but they're in that that's their electron shell. Okay? What do we call the vertical columns? We call these groups or families. So what's meant by a group? D. And if they're in the same family, they have the same valence shell, And they often have very similar properties. They'll often bond identically with other elements in the same way as other elements in their same family. Which phrase correctly describes for both the sulfide ion, S2 negative, and the oxide ion, O2 negative? Let's see. Do they have more protons than electrons? If you become negatively charged, what does that mean? If you become negatively charged, have you gained protons or have you gained electrons? So they've gained E negatives. There's our symbol for electrons. So they don't have more protons than electrons. What they do have is more electrons than protons. Normally, Kiana, on the periodic table, elements are neutral, which means they have the same number of protons and electrons. That's an atom. But when it's an ion, that's changed. Which of the following is a covalent compound? Okay, what was the difference between an ionic compound? How could you tell just by glancing at something that it was ionic or covalent? Anybody remember? Sorry? The answer is B. How can you tell? Ionic is metal followed by a nonmetal. Covalent is two non-metals. So this is not a compound, it's just iron by itself. This is a nonmetal and a nonmetal, that's a covalent. This is not a compound, it's just oxygen by itself. This is a metal followed by a nonmetal. It is B. Number 9, how many atoms in total are represented by this formula here? Oh, okay. Yo.
You said, it says which of the following is a...
Oh, it's a covalent compound. Sorry. Thank you. Candy for Kevin. Covalent compound is that one there. Because that's a compound, it's got more than one element, and it's a non-metal. Read the question, Mr. Dueck. Thank you very much. Number 9, how many atoms in total are represented by this formula here? Okay. How many of those are there? How many Fe's? How many irons are there? What number is sitting right down here? It's invisible. 1. Now, how many of these C's are there? Well, right here there's 1, but what's outside the brackets? So it's going to be 1 times 3, which is 3. How many H's are there? Not 3, but 9? Or is that a German saying no? You'll miss that joke. 9? No? 9? Okay. How many of those are there? 3. How many of those are there? 3. How many of those are there? 3, because they're all inside the bracket with the 3 on the outside. There's 1 of each of them inside the bracket, but that 3 on the outside means you've got 3 of them. How many atoms are there grand total? 1 plus 3 plus 9 plus 3 plus 3 plus 3. 22. Okay? 1 bad apple in a barrel causes the whole bunch to turn rotten, causing them to turn brown, get warmer, and become mushy. Which kind of changes are involved? Physical change only, that is exothermic. Okay, first of all, get warmer. If it gives off heat, is that endothermic or exothermic? Remember I showed you those heat pads that gave off heat as an example of what? So this is going to be exothermic. So I'm going to cross off B, and I'm going to cross off D. Now, is an apple rotting a physical change or a chemical change? Well, there's a key question. For a chemical change, something new must be produced. And when an apple rots, you do actually have, it's combining with oxygen in the air, it's forming a new chemical. It is a chemical change. It's also because it's not reversible. Hey, some matching. When I do matching, now on your exam, there is no matching, but this is still, there's going to be vocabulary questions just as multiple choice questions. Question, Amelia or Jordan? What was 10? C. Exothermic, it says it gets warmer, gives off heat, and it's a chemical change because something new is being produced, and also it's not easily reversible. Okay? Amelia, if I have to do matching, I actually start with the terms. I never read the definitions. I look at the term and then I go try and find the definition because I find that my brain works better that way. On your test, on your final, there is no matching, but there is vocabulary, so it's still good practice. So, alkaline earth metal. Well, actually, sorry, I look at the definitions and go find the words. I said that totally wrong. I do it that way, yep. So an example of a physical property. Maybe boiling point. Each term may be used only once. Let's come back to that. What's the smallest particle of a piece of iron? What's the smallest particle of a piece of gold? What's the smallest particle of a piece of carbon? Atom. I think that's what they're getting at here. I think that's going to be B, and I'll cross that out. Water is an example. That's pretty vague. I'll come back to that in a second. I'll handle that later. Cannot be decomposed by chemical means. Not sure what that one's getting at either. I'll come back to that. Elements in this family have 7 valence electrons. That one I know. Elements in this family have 7 valence electrons. Which ones have 7 valence electrons, which means they're right before the noble gases? Jordan, you with me? Okay. It's a halogen. Number 15 is a halogen. The halogens have 7 valence electrons, which is why they're so reactive. They just need one more electron to fill their shell. What's a model that shows how electrons are arranged? This is the Bohr model. Yeah, Bohr diagram, but they said the word model, so okay. Cross out E. What subatomic particle has no electric charge? Neutron, that's going to be L. This number identifies the element. Atomic number. Also tells you how many protons and how many electrons. Involves shared pairs of electrons. This was covalent, and I always remember that covalent you're sharing, because another word for sharing on Sesame Street is cooperation, covalent, right? Contains a metal and a nonmetal. That's an ionic compound. I should have crossed out covalent compound. I should have crossed out ionic compound. Okay, now I can go back here. Sorry? I used I twice. I said ionic, which is J, Mr. Dueck. Thank you. All right. From what's left, water is an example. I think it's a molecule. It's a lousy question, I think. An example of a physical property, I think that's a boiling point. Cannot be decomposed by chemical means. I think what they're getting at there is an element. And I think we got them all. So, some other concepts from chemistry, nearly done. Using kinetic molecular theory, how can a solid turn into a liquid? What's going on the particle level? How can a solid turn into a liquid? Sorry? Okay. If you add heat, what does that do?
Gets heated.
It adds kinetic energy to particles. They move faster, so space between them gets bigger. And when the space between them gets bigger, instead of a solid, what does it now become? A liquid. This is why heating something up melts it. You add heat. That's step one. What does that heat actually do? What it does, Kiana, is it actually increases the kinetic energy of the particles. It makes them move faster. And when the particles move faster, they bump into each other more. The space between them gets bigger, liquid. And if you add more heat, you get more space. Instead of a liquid, what do you get? Call that boiling. Okay? Number 22 says, draw a sketch of an atom containing 5 protons, 6 neutrons, and as many electrons as are needed to make the atom neutral. I'm going to do that down here because I have room down here. So if I was drawing an atom, how many protons does it want in the nucleus? 5? It says 5? Okay. How many neutrons does it want? 6? And it says, how many electrons will I need to make this neutral? 5. So what's that going to look like? Am I going to do this? 1, 2, 3, 4, 5? No, we had this idea that each shell could only hold a certain number of electrons. So you had, in the first shell, how many electrons? This was in fact, we called it, Lena, the 2, 8, 8, and then 18, then went kind of crazy. But certainly the first 3 shells hold 2, then 8, then 8. So there's 2. How many more am I going to need to draw? 3 more, and they're going to be separate. They start pairing off. Once you have 4, they start going in pairs. What element is that, by the way? What is an element with 5 protons? What is element number 5? Boron, is that right? Okay. Yep. I won't be asking you to draw a Bohr, but I will be asking you to interpret a Bohr diagram. Okay? Let's go back up here. So done. Oh, sketch a Bohr diagram. Let's just do one of these. Let's do Al3+. Okay? So we start out going like this. There's the nucleus. Aluminum, how many protons, and how do I know? Aluminum, how many protons, and how do I know? So 13 protons. How many neutrons, and how do I know? How'd you figure that out? Mass minus proton, because electrons basically weigh nothing. All of the mass, by the way, this would be a good question. All of the mass comes from protons and neutrons, almost all. All of the space comes from the electrons, because remember I showed you that video, the nucleus is really, 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 really small. It's the electrons that make up most of the space of an atom. So, sorry, how many neutrons? 14? All right. How many electrons? Well, in the first shell, 2. In the next shell, 1, 2, 3, 4, pair. Now, look at what they gave me. Am I drawing aluminum? Not exactly. What am I actually drawing? Aluminum what? Aluminum 3+. This is an ion. Now, if I was, don't write this down. If I was just drawing the atom, I would go like that, and I would say, how many more do I need to draw? 3. And I would go 1, 2, 3. That's the atom. Because this is an ion, it's lost its valence electrons. It gave them to a nonmetal. I don't know how or where, but it gave them to a nonmetal. Can you put both face down in block F, please? So to show that it's an ion, that I did this on purpose, we said the convention is you put square brackets. That tells the person, that's an ion. And then you put the ion charge right there as well. Went okay? No telling anybody else any questions. Okay? So going to your question, Amelia, I would have no problem giving you a picture like that and then saying, in fact, a picture and saying what element or what is this, and one of the answers would be the atom without the ion charge, and one would be with the ion charge, and you'd have to look at the number of protons to figure out the atom, right? Use the periodic table to identify these elements. The metal in period 5, group 11. So period 5 is row 5. Group 11 is column 11. I got a periodic table up here. 1, 2, 3, 4, 5. I think this is a shiny one. Silver. Silver. Or, as I like to say, Ag. What's the element with an atomic mass of 16 atomic mass units? Oxygen. The metalloid in the second period. Metalloids, what are those? Those were those things that kind of behaved sometimes like a metal and sometimes like a non-metal, and they're right along that staircase. So the metalloid in the second period is boron. That's why that thick staircase is there. B. The metal in period 4 with three different ion charges. So let's see, in period 4, row 4, a metal that has 3 common ion charges. I only see one that has 3. It's multivalent. It's got 3 different charges. Which one? Manganese, Mn. The halogen, whose atoms are heavier than sulfur's atoms, and which has an atomic number less than selenium. Say what? The halogen, let me find my periodic table. The halogen, that's this column here, that's heavier than sulfur, but less than selenium. I think we're talking chlorine, right? Says list 6 chemical or physical properties typical of alkali metals. What are the alkali metals? Which row is the which group, which column is the alkali? Sorry? Very first one, the one on the left. What do you remember? I showed you some videos because they're very hazardous to play with. I had to show you videos. What are some things you remember about the alkali? Sodium and, lithium, sodium, potassium, rubidium. I think I even showed you cesium, but francium, you need government permission to get access to you. What do you remember about those? When? Remember these ones all blew up in water? Remember what color they were? They were all silver. They were very soft. In fact, you saw in the video, he cut them with just like a standard knife. You think, how can you cut metal with a knife? They're very soft. Okay? Other stuff, because they're metal, they are conductors, because they will conduct electricity. They want 6 different properties. Well, they all have 1 extra electron in their valence shell, which is why they're so reactive. Can you put it face down in the appropriate block? Thanks, sir. What else do I remember? 1, 2, 3, 4. I got 5. Good enough. What I really want to spend the most time on is 26 and 27. Writing names and writing formulas. And this is really where you need your periodic table. So write names for the following compounds. Here's what we said. You have to ask, is it multivalent? If it's not multivalent, it's way easier. If it is multivalent, it was more work. So find on your periodic table, Riley, sodium. Found it? Sodium, multivalent or not?
No.
Then we just would call this sodium chloride. This was the IDE rule. What about magnesium? Find magnesium on your periodic table. Is it multivalent or not?
No.
So this was going to be magnesium. Magnesium what? What's the P? And then we did the ide rule, so it became phosphide. Put the phone away, kiddo. Hey. It's got to wait. Iron. Is iron multivalent or not? This is going to be trickier. Now I have to actually look at my options. I have to crisscross. Guys? Okay. Here's iron. Here's oxygen. What's the valence charge on oxygen? What's the valence charge on oxygen? Did you hear, folks? What's the valence charge on oxygen from your periodic table? All of you right now should be looking at a periodic table, should be finding oxygen, and should be telling me what the valence charge is. 2 negative. What's the valence charge of iron? Well, it depends. Iron is multivalent. But it looks like when I did the crisscross trick, I ended up with 1 and 1, because when I look at the formula here, it's 1 iron and 1 oxygen. How the heck can that work? Well, when I crisscross, I would have a 2 there from the oxygen. What could I have right in this spot so that I would end up with a 1 and 1 when I reduce? Lena, you were right, I think, a 2. So what must the charge have been on iron? Must have been, you know what? This is going to be called iron, Roman numeral. I used the 2 oxide. It was a while ago. Oh, D, these are those polyatomic ions. This is on the back of your periodic table if it's the pink sheet. If you borrowed the booklet, you have to turn a couple of pages, but you will see that page does show up in there somewhere. There is. So if you have the booklet, find the polyatomic ions. They are there somewhere. You have to turn the page a little bit. Okay? What is NH4? So this is going to be called ammonium. What is PO4? Phosphate, not phosphite. I always got to double check because there's both. It's phosphate. Okay. Last one, PT. What the heck is PT? What's PT? Is platinum multivalent or not? It is? Okay, so I'm going to have to use Roman numerals here. I'm going to have to uncrisscross. So I go off in the margin and I say, okay, platinum, I don't know what its charge is. What about SO4? What was its charge? What's SO4's charge? How many SO4s did I need, though? 2? So 1 is 2 negative, but I needed 2 of them. Why would I have needed 2 of them? What must the charge on this guy have been? What's the total charge here? If 1 is 2 negative and I have 2 of them, what's the total charge there? If 1 of them is 2 negative and I have 2 of them, what's the total charge on the right-hand side there in negatives? Negative 4. I got a total of negative 4. So for this to be neutral, I better have a 4 plus over here. This must be, PT is platinum, you said?
Yes.
Platinum, bracket, Roman numeral IV, 4. And what's SO4? Sulf what? Sulfate? Those 2 questions, C and E, are probably the trickiest writing names Even my Science 10 students still struggle with them. Writing formulas is a little bit easier. This is where we use the crisscross rule. So over in the margin, we wrote calcium. What's the atomic ion? What's the ion charge on calcium? 2 plus. Then we wrote bromide. What's the ion charge on bromide? And then we said we use the crisscross. We went like that and like that. It's going to end up being calcium, 1 of them, bromide, 2 of them. It was crisscross and reduce if you could reduce it to lowest terms. Copper 1 phosphide. Okay, copper is multivalent. How do I know which charge copper symbol is Cu. How do I know which charge they want me to use? The Roman numeral. They told me, use the 1 plus. Phosphide, which I think is the P. What's the charge on phosphorus? Sorry?
It is
3 negative. So when I crisscross, I will end up with 3 coppers, 1 phosphide, Cu, subscript 3, P. What about potassium carbonate? I'll do that one over here. Potassium has a charge of 1 plus. What the heck is carbonate? It's a polyatomic ion. What is it? Sorry? CO3. What's its charge, please? 2 negative. So when I crisscross, I'll end up with 2 potassiums and 1 CO3, so I don't need to put brackets or anything like that. What about aluminum hydroxide? Okay. Aluminum, I think, is 3 plus. Hydroxide is OH negative. When I crisscross, I'm about to make a mistake. See if you can spot it. Where's the mistake? What did I do wrong? To show that I need 3 OHs, I'd have to put it in brackets to say I need 3 of those. Sorry? This is hydroxide. It's a polyatomic ion, right? It's from that polyatomic part. Okay? You guys are kind of getting a little squirrely here. I'm going to skip E. What's the difference between a physical change and a chemical change? Key idea. In a chemical change, what? Something new is produced. So, the difference between a physical change and a chemical change, something new is not produced. Okay? Can you give me an example of a physical change? Can you give me an example of a physical change? Tearing a piece of paper. You've made it look different, but it's still paper. Nothing new is produced. Breaking something up. Boiling or melting, all, like freezing, sublimate, those are all physical changes. You give me an example of a chemical change. Burning something, because you're combining it with oxygen when you burn something. Baking or cooking something. Okay. So there is a very, very quick review of chemistry.